All right. So we're going to start off with chapter 4, lesson 1. Um, it's going to be classifying triangles. So in this lesson, you're going to be able to identify and classify triangles by angle measures and the side measures. All right. We're going to go through a couple different ways to go about that. But the first part I'm going to show you is this triangle that's right here, this little A, B, and C. So when we have the triangle, we're going to have the sides AB, again, with the line over the top to show that it's a line. We've got line BC, and then we've got line AC. Okay, no matter what, we're going to have 3 lines because it's a triangle. Okay, 3 lines because each side of a triangle is going to have its own line. So there should be 3 of those. Just like with angles and vertices, it is a triangle, so we're going to have 3 of each of those. So the 3 angles that we have, remember, it is going to be identified by the middle letter. So my first triangle I'm going to have will be triangle ABC, A, B, C. Okay, to show you what that is, I'm just going to put a little highlight here. ABC is this angle right there. Okay. On to the next part. I'm going to erase that. I've got the next angle is going to be angle B, C, A. Okay, that's going to be this one here. And the very last triangle that we're going to work with, the last angle we're going to have is going to be angle CAB. Okay, and that's going to be this angle right over here. All right, so those are my angles. And then vertices. Vertices are the points that are going to be on the corner. There are 3 of them because it's a triangle. I've got vertice A, B, and then C. Again, each vertice is the point that the triangle has. All right, next part is going to be classifying triangles by their angles. All right, there are 3 different types of them. We've got acute triangle, equal angular triangle, obtuse triangle, and then a right triangle. So for each of these, an acute triangle, I'm going to write some definitions underneath it, but acute triangle, no angle is over 90 degrees. Okay. Every single thing is going to be smaller than 90 degrees. All right. Equiangular triangle. This one means that every single angle is going to be the exact same. And in a triangle, that means every single angle is going to be 60 degrees. So all angles are the same. And because triangles are going to add up to 180, and we're going to talk about that some more, but that means they have to all be 60 degrees. No matter what, that's the rule. All right. In an obtuse triangle, there will be one angle that is bigger than .90 degrees. Okay, it has to be bigger than 90. It cannot be exactly 90. Because if we had exactly 90, this is when we get the right triangle. So in the right triangle, one angle is exactly 90 degrees. And again, I apologize for my handwriting. So those are the 4 different types of triangles we have. So now that we kind of get a good idea of those, I'm going to go down to these angles down here where it says use the best description to classify each triangle. Are they acute, equiangular, obtuse, or right? All right, for number 1, every single angle is the exact same number, is exactly 60 degrees. Because of that, this one is going to be equiangular. Okay. Number 2. Okay, looking at these angles, I've got a 20-degree angle, a 30-degree angle, and a 130-degree angle. Because I have one angle that is more than 90 degrees, this would be an obtuse triangle. Okay, that's this angle right down here. Because that one was above 90 degrees, that's what makes it obtuse. All right, for number 3, I've got a 70 degree, and 40 degree. Okay, they are not all the exact same number. 2 of them are, but not all of them are. So looking at those, none of them are bigger than 90 degrees, and none of them are exactly 90 degrees. Because of that, this is going to be an acute angle, and then acute triangle. All right. Next part. Here's where we're going to start looking a little bit more closely on these ones, and it's going to be a little bit of extra work. Okay, I'm going to get a highlighter out, so bear with me while I grab that. This one says I need to classify each triangle as acute, equiangular, obtuse, or right, just like we had before. Okay, and it says explain your reasoning. Hopefully it'll make sure that you'll understand this way. I need to find triangle XYZ. I got that highlighter for a reason. I'm going to highlight the entire triangle. XYZ is going to be X to Y, Y to Z, and then back together. This is this entire angle, or the entire triangle. So I've got one angle up here, that's 50 degrees. This one down here is 40 degrees. However, this very bottom angle, I'm not certain of. So let me get a pen and let's figure that out. All right. With this angle, I've got a 40-degree angle and I've got a 50-degree angle. That means I've got a 40 degrees plus 50 degrees, and I'm going to add those together. 40 plus 50 is 90 degrees. Because of that, it's telling me that this corner down here is exactly 90 degrees. If that angle is exactly 90 degrees, then that triangle XYZ, is going to be a right triangle. Okay. Next one, I'm going to go down to here. I've got triangle PQR. I'm going to get a highlighter again, just like I did last time, just so I can show you which triangle we're working with. Oops, sorry about that. Triangle PQR. I've got this angle here, up to the top, all the way over there, and then all the way over there. Again, make sure you know exactly which angles they're talking about, because there are going to be times when I give different angles with, it might be the smaller triangle on the inside. But anyway, I've got angle PQR. Let me grab another pen, a different color to work with, and back up to it again. All right, I've got angle PQR. This angle down here is 31, so I know that. This angle's 45 over here. Ooh, this one on top, I don't know because there's 2 of them. I've got this 45, and I've got this 59. So I'm going to add those together. I get 45 plus 59 to figure out how big that entire angle is. Okay, if I add those together, I get, that's 14, carry the 1, I get 104 degrees. This angle right here, kind of make a little arrow that lets you know what it is 104 degrees. Because that's 104 degrees, that is bigger than 90, that makes this triangle an obtuse triangle. Okay, that's it for the classifying triangles just by those angles. Now we're going to get into classifying triangles by their sides. Again, we have 3 of them. Okay. Equilateral or equilateral triangle means that all sides are the same. So all sides are the same. That's what this red hash, this red hash, this red hash are meaning. So that's what an equilateral triangle is. An isosceles triangle means 2 sides are exactly the same. And the last one, the scalene triangle, means that no sides are the same. Okay, so that's my equilateral, isosceles, and the scalene triangle. So let's look at a couple samples. We're giving you some real life ones. It says the sound box of the Russian lute below. See if it's equilateral, isosceles, or scalene. Remember, equilateral means they're all the same. Isosceles means two of them are the same. Scalene means that none of them are the same. So I'm going to look at these numbers. I've got a 16, a 16, and an 18.5. Out of this, I can see this 16.5 or this 16 and this 16. If it's a triangle, these ones are going to be the exact same measure, which tells me that that is an isosceles triangle. All right, next one. Classify the hazard light button. Same way. So I'm looking at that triangle. One side's 0.75, the other one's 0.75, the other one's 0.75. If I look at it, every single side is exactly the same length. That tells me it is an equilateral triangle. So on to classifying some triangles within those figures by their sides. Okay, they're going to give us some information. We're going to have to solve some things. This is taking a little bit of what we did a couple chapters ago or last chapter and using it for this test or for this assignment. So it says if point Y is the midpoint of V and X, if it's the midpoint, that tells me that this side and this side are exactly the same. Okay, so point Y is the midpoint of V and X, and WY is 3 units. So I'm going to write that in there. W and Y is 3.0 units. Okay, that's my decimal point right there. Classify it as equilateral, isosceles, or scalene. Okay, I've got 3 of the measures, but I do need to know what this on the bottom is. The entire thing is 8.4, and if that's the midpoint, that tells me that both sides are going to be exactly the same. So I can take 8.4, and I can divide that one by 2, and that lets me know that each side of that is going to be 4.1, and the other one's going to be 4.1. So I've got 4.1 there, 4.1 there. I've got all my numbers. I can start to put it together. It says triangle VWY. I'm going to get that highlighter again, so bear with me. VWY. I've got VWY. I'm only looking at this triangle right here. I've got a 4.5 unit, a 3.0 unit, and a 4.1 unit. So what type of, let me get my pen again. What type of triangle do I have? That one is going to be scalene.